Okay, the question is on 21, and what I was saying is that every year I put this type of problem on the test, and it's an easy enough question if you understand what they want and how to use your calculator. Okay, so 21, solve the equation graphically by finding x-intercepts. So first of all, notice it says graphically. I don't want you trying to solve that algebraically. I want a graph, okay? I gave you the hint here on the worksheet. I don't remember if it'll be on the test. Use the graphing calculator. But notice what it says. This part will be on the test. By finding x-intercepts. What is that on the calculator? What is that called when we do that on the calculator? What's the menu choice we go in and pick? X-intercepts are another word for zeros. So we're going to be finding our zeros. So first thing you want to do is you want to grab your calculator and graph that equation. So I'm going to graph x squared minus x minus 4. I personally saw that I was zoomed in on whatever I last did on this. So good thing to do is to always just start off by, I like to do the number 6, Z standard, just something to give me a basic 10 by 10 screen. Okay, so the shape is a parabola, yes? So if this shape is a parabola, and you don't have to sketch this on here, but I'm just sketching this. What do I want to know when it says find the x-intercepts? I want to know 1 and 2 places where it touches the x-axis, right? So, with that in mind, do you remember the technique here? Second, and the trace button, which is the calc menu. And then we're going to go down to number 2, which is the 0 option. So second, calc, and then we're going to go to 0. And this is where it asks you the questions. Let your calculator guide you. So, if I'm trying to first of all find this 0 over here, sorry, it's awkward to point here, but if I'm trying to find this 0 over here, I need to first of all find the left bound of this one, which means I need to take my cursor left of this point where it crosses the x-axis right there. So by taking it up there, I am left of it. I'm going to hit enter. Now, that same point, and if I look at that point, it's what, -1 point something? Now I'm going to go past it because it says right bound question mark. So now I want to be to the right of this spot where we're crossing the x-axis. And I'm going to hit enter again. The guess, just take your cursor back to the approximate spot you're trying to locate. And I'm going to hit enter. And notice when I get to my final answer, it says 0. That's how you know it's providing you an answer. And so I think I have 2 decimal places on the answer key. I do. So the first one, x is approximately, well, the calculator answer is -1.561553. I have written down -1.56 as an approximate answer. And then we repeat the process, right? There's not a way to just do it once and get both answers. So now I'm going to go repeat the process. I'm going to again go into second, calc, which is that trace button. And I'm going to either hit 2 or I'm going to arrow down to 2 and hit enter, which is 0. Now, this time, I'm wanting to find this point, right? I know it's hard for me to get my pen at the right angle there. I want to find that point where we're crossing the x-axis. So now, I want my cursor to be somewhere to the left of it, which can be anywhere on that graph below it. Hit enter. Bound part. So now I need to be to the right of it, which means I'm going to go through the x-axis. Now I'm to the right of the point in question. Hit enter. And then guess I'm going to go back to right there where my pinpoint is, and I'm there. This time by 0, 2.5615528, or approximately 2.56. Now, I will say, good to give partial credit because there's not work to show, is there? It's you doing it on your calculator. So, one thing, and I don't know that I've really said it a whole lot, always double check when you type something in, did you type it in right? Okay, that can save you some basic points, but just by checking, okay, x squared minus x minus 4. Because it's so easy to hit a wrong button or minus instead of plus, and you don't want to do that. Okay? So probably a good one to look at. You guys have others you want to look at? Ethan?
Sure. Let's do
24. Okay. So 24 says write the product in standard form, which it's not stated right there, but it is on the section up above. Standard form means we are looking for A plus BI, right? Real plus imaginary. Now, what I would do to start 24, when you are provided a problem like this, before we get into this, let's simplify the square root of negative 9. What is the square root of negative 9?
I mean, I know it's I squared. No, it would be I. That's the part that always gets me. It's like I put like something like 9i or something.
Okay, except it's not 9i. So what I look at is, okay, square root of negative 9. If I separate the negative 1, it's negative 1 times 9. Can we take the square root of negative 1? Well, that's what we use as an I. Do we know the square root of 9? It's 3, isn't it? If you know that square root, go ahead and take it. If this had been the square root of 5, which is not a perfect square, then we'd say I square root of 5. Since we do know this square root, we're going to say 3i. So I'm going to rewrite this problem as 3i plus 3i times 4 minus 2i. That's my suggestion there. Okay? Now, you have two options. You can start foiling at this point if you want. Or there's something that will make life easier if you catch it. What will make life easier here? Yeah, 3i plus 3i. Aren't those like terms? We get so used to them not being like terms, we just assume they're not. And as I said, if you don't add them right here, you FOIL, it'll all work out in the end. Okay? So if you want, you could say 3i plus 3i, which is 6i. And then we have 6i times 4 minus 2i. And if I do 6i times 4 minus 2i, that means I'm going to distribute. So, (24i) minus 6i times 2i. 6 times 2 is 12. I times I is I squared. What can we not leave in our answer here? Yeah, what do we know about I squared? It equals negative 1, doesn't it? So minus 12i squared really becomes, instead of minus 12i squared, we're going to say plus 12. And then if you want to be official, which probably we should, this is bi plus a, we really should, standard notation is to flip around. And so to rewrite it as 12 plus 24i. Okay. about completing the square? How do you guys feel about completing the square? Like number 19. Can we handle that for tomorrow? Some are saying, some are like, yeah, and others are giving me looks like, maybe. Now, first of all, you have your pink paper, yes? And I don't even, I'll be honest, how did I phrase the steps on the pink paper? Because that's what you have going into this test. Goodness, I can't reach it. That's what you have going into this test that's your helpful stuff there. So first of all, initial form, x squared plus bx plus c. Do I have that? And I do. I do have the x squared plus bx plus c. So then you'll notice it says add b over 2 squared to both sides of the equation. And that's what we're going to do next.
Sorry, yeah, that's info. So.
Okay. Okay, so you got the committee information off the bottom?
I just wanted to give it to you.
Okay, thank you.
Yeah. Hey, I think Tyler will be coming. So,
Okay.
because I told her, I said, well, Leah, I knew you were going to tell me that.
She would have known because of our discussion at lunch, so.
Yeah. All right, see you later.
Okay. Okay, so we have x squared plus bx plus c. We're going to add b over 2 to both sides. So, what is b? B is 8. So you need to do 8 over 2 squared. 8 divided by 2 is 4. 4 squared is 16. So that 16 is what we're going to add to both sides. So I'm going to rewrite this problem out. I'm going to have x squared plus 8x, I'm going to leave a gap, equals 3. We found b over 2, so we're going to add it to both sides. Because what you do to one side of an equation, you do to the other side, right? Okay, the next thing it says on your steps, factor left side of the new equation. Do you remember what that factoring looks like? Because it always looks the same. Parentheses squared. That's the whole point of completing the squares. We made it a perfect square. The square root of x squared is x. Then what I like to say is what's the square root of 16, which is 4. What was the middle sign on the 8? And that was a plus. It's also been pointed out, how did we get 16 right here? It was 8 over 2, which was 4, right? So that's the same thing. Clean up the right. 3 plus 16 is 19. Okay. X plus 4 quantity squared. I guess I still have one more step. It says solve by extracting square roots, which really just means you're being told to take the square root of both sides. What's the square root of x plus 4 squared? X plus 4. What's the square root of 19? And? Plus or minus the square root of 19. Now, officially we don't have any more steps, but it was solved by extracting the square root, so you keep solving. How do I get x by itself? If it's x plus 4, we're going to subtract 4. And so I like to write this answer as x equals, and I like to have my plus or minus in the middle, not that you have to, but negative 4 plus or minus the square root of 19. Okay? The hand sanitizer?
Yeah, the bad stuff.
It's all bad stuff, though. Isn't that what you decided? It all stinks.
It's like in every room, too. It's not even just...
Well, it all comes from the same place for the most part, unless someone went out and bought their own separate stuff. But I guess the only answer is to carry your own hand sanitizer if it's that horribly bad. If you can tolerate it, it's there for you. Okay. I just thought completing the square was a good one to maybe review. know how to do the parallel perpendicular stuff. Oh, I see. Let's see. I don't have. Some of you are going to say this sounds silly, but some of you are going to say, no, I need this. Number 10. Silly, not silly, I don't know, but it has fractions in it, so that makes it a good one. And I'm looking at, there was a problem like this on the quiz, and it was troublesome for some of you. Okay? So, I see a bunch of fractions. How do we get rid of fractions? Well, fractions are dividing by something, so we want to do the opposite. We want to multiply. So, think, what do 2, 5, and 4 all multiply into? So what we think of as like a least common denominator. We're not going to get a least common denominator, but that's what we're going to multiply by. 2, 5, and 4 all multiply into 20. Because 4 and 5 would be 20. 2 goes into that. So what we're going to do is we're going to multiply both sides of this equation by 20. Now, think of that as 20 over 1, if you will. And you know what? I'm going to write this out the long way, just because, as I said, some of you could use it, I think. We're going to multiply 20 over 1 times 9x plus 6 over 2, plus, we're going to multiply 20 over 1 times the 6x minus 5 over 5, and we're going to multiply 20 over 1 times the 5 over 4. So some of you don't need that extra step right now. That's fine. But again, I'm concerned because I saw some issues on the quiz I didn't like. Every piece is being multiplied by 20 as a fraction, 20 over 1. So in this first set, guys, it's cross-canceling. 2 and 20 can both divide by 2. 2 divided by 2 is 1. What's 20 divided by 2? 10. And so this now becomes 10 times 9x plus 6. Plus. Okay, next set. 5 and 20. 5 and 20 both divide by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So then we're going to have 4 times 6x minus 5 equals, on the right, 4 and 20 both divide by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. And so then I have 5 times 5. From here, I'm not as concerned about going from here. Most of you should have the idea here. So I'm going to distribute 90x plus 60 plus 24x minus 20 equals 25. Then I'm going to clean up like terms. 90x and 24x, they're on the same side of the equation. Don't do anything crazy like trying to subtract them over. Just put them together. 90 and 24 is 114x. 60 minus 20, they're on the same side. Do what it tells you. 60 minus 20 is 40. So plus 40 equals 25. If it's 114x plus 20, or excuse me, plus 40, I'm going to subtract 40. 114x equals negative 15. It's 114 times x. Divide by 114, and x is, I would say, negative 15 over 114. However, I know 15 divides by 3, and 1 plus 1 plus 4 is 6. So that means 114 divides by 3. I don't know if you guys remember that divisibility rule. If the sum of the digits divides by 3, the number divides by 3. Yeah, so this becomes negative 5/38. Okay. That's another good one to look at. Parallel, perpendicular, know how to do that. Yes.
Did you do 17 real quick?
Yes, I can. Okay. So 17, the issue more than anything is I don't have the steps written out on the answer key, do I?
Yeah.
So 17, for whatever reason at the time, I didn't do product of AC on it. But that's what this is. Okay. Short on time, so I'm shortcutting. This is product of AC. It already equals 0. There's an A value, so product of AC. A and C, 3 times negative 5. So this is going to be a product of negative 15. A sum of B, which is negative 14. What multiplies to be negative 15 and adds to be negative 14? It's got to be a 15 and 1, negative 15, positive 1. So what we're going to do, I'm going to bring this over here. It was 3x squared minus 14x minus 5 equals 0. If we're using negative 15 and 1, we're going to split that middle term. Doesn't matter which way you split it. So 3x squared stays 3x squared. Then this can become minus 15x plus 1x, carry down the minus 5, equals 0. 4 terms, so we're going to split it in half. GCF of the first two. 3x squared and 15x both divide by 3x. So then I'm left with x minus 5. GCF of x minus 5. There's nothing, but there's always an invisible 1. So I'm going to put plus 1. And then it's x minus 5. 2 parentheses here, right? My 2 parentheses, the x minus 5 in common, and the GCFs of 3x plus 1. And from there, it's set each part equal to 0, isn't it? Is that what you need to see, Jacob?
Yeah.
I don't think it's this final part you guys really needed to see. So, okay, guys, test tomorrow. Be ready to go. Stop me if you have questions before school, after school, homeroom. Okay?